estimating a population proportion. Here's the summary of what's coming up. The first thing we want to discuss would be the margin of error and confidence interval for estimating a population proportion P and determining sample size.
When data from a simple random sample are used to estimate a population proportion P, the margin of error, maximum error of the estimate, times the error bound, denoted by E, is the maximum likely difference with probability 1 minus alpha, such as 0.95, between the observed sample proportion P hat and the true value of the population proportion P.
One thing I want to make a point of, depending again on the text that you're studying, this is called a margin of error, maximum error of the estimate, error bound. So those are different names that you can see. Now, to start building up a confidence interval, you need to start from somewhere. Where do we start with? P hat. And then we make up an interval that hopefully contains the true population parameter. And that's the idea behind that. So what we have here is P hat plus minus E. That E was the error bound, the margin of error. So P is between these two values. And then we can see how E is calculated, and we go to the right and left of it. If the interval of P hat minus E, P hat plus E. Now the endpoints may or may not be included, so you can go with brackets or parentheses. But more importantly, notice the end of the interval, the endpoints, P hat minus E and P hat plus E. So when I say UCL, that means upper confidence level or limit. So the upper confidence level or limit is P hat plus E. The lower is P hat minus E. And if you add them up and divide by 2, it gives P hat. If you subtract and divide by 2, it gives you the margin of error E. And at the bottom, we calculate the N. We will discuss that further in a moment as to how N is calculated and where P hat and Q hat are given or they are missing. So this is the synopsis of that. So N is Z alpha over 2 to the second power, P hat Q hat over E squared. If P hat is missing, then you assume they are equal, and they are equal to 0.5, and that gives you a more conservative estimate. So this is the synopsis.
Use a sample proportion to make an inference about the value of the corresponding population proportion. A point estimate is a specific numerical value estimate of a parameter. A point estimate is a single value or point used to approximate a population parameter. The sample proportion P hat is the best point estimate of the population proportion P. P is equal to X over N is equal to population proportion. P hat is equal to X over little n, which is equal to the sample proportion. Q hat is equal to 1 minus P hat. X is the number of sample units that possess the characteristics of interest, and N is equal to sample size. X is the number of population units that possess the characteristics of interest, and N is equal to population size.
You want to build up a confidence interval. Where do you begin? Somewhere. What is it called? Point estimate. What is the point estimate for P? P hat. What is the point estimate for mu? X bar. So that's important to understand.
Properties of a good estimator. The estimator should be an unbiased estimator. That is, the expected value or the mean of the estimates obtained from samples of a given size is equal to the parameter being estimated. 2, the estimator should be consistent. For a consistent estimator, a sample size increases. As sample size increases, the value of the estimator approaches the value of the parameter estimated. And 3, the estimator should be a relatively efficient estimator. That is, of all the statistics that can be used to estimate a parameter, the relatively efficient estimator has the smallest variance.
When we look up estimator, it has a specific property that we have to look into one by one. Unbiased. What is unbiased? The definition is given. We've already looked at that. And then, so when we look at later courses, this is discussed further. The concept of unbiased estimator. consistent estimator and efficient estimator. Those are the three properties. One by one is discussed with a lot more details later on. I just wanted you to be exposed to basic idea behind the concept here. So again, unbiased, we've seen it, the expected value of the mean from a sample of a given size is equal to the parameter being estimated. That means you take the average and it should work out. Consistent means as n gets larger, it gets closer to the actual population parameter, and efficient means a fairly small variance.
Confidence interval. We can use a sample proportion to construct a confidence interval estimate of the true value of a population proportion. Sample size. We should know how to find the sample size necessary to estimate a population proportion.
A survey of 1,500 adults indicated that 48% of them have a Facebook page. Based on that result, find the best point estimate of the proportion of all adults who have a Facebook page.
What is the best point estimate for P is P hat. Now, what is given? It is important to understand we are dealing with a binomial distribution. Why is that? You have it or you don't. What do you have? You have Facebook page or you don't. There are two outcomes. So if that is a binomial distribution, we need to know two things. What is the value of n?
1,500.
And what is p?
0.48.
And so practically we're done as long as we recognize that the point estimate, or short PE, for P is P hat is given as 0.48. Excellent.
In a recent survey of 200 households, 60 had central air conditioning. Find P hat and Q hat, where P hat is the proportion of households that have central air conditioning. X is equal to 60 and N is equal to 200.
Notice that there are two outcomes. That's the main thing. Of course, in dependency, the probability stays the same. All of the above is fine and dandy. But understand, we have central air conditioning or we don't. Two outcomes. So it's binomial distribution. And so if it's a binomial distribution, we need to know N and P. Now, remember, P is the population proportion. In many cases, it is not available. Let me just go back and change this to P hat. So N is 200 and X is 60. So to get to P hat, we have to calculate using X over N. I hope you remember that we discussed that as far as the formula is concerned, P hat is lowercase x over lowercase n. P is capital X over capital X. And so to come up with the answer here, to come up with P hat, we just use the formula lowercase x over lowercase n. Remember, 260 out of 200. And that's P hat. Now, Q hat is just 1 minus that. Q hat is 1 minus P hat, just the way we calculate Q1 minus P. Let's look at some more concept so we can move on.
A confidence interval or interval estimate is a range or an interval of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated as CI. This estimate may or may not contain the value of the parameter being estimated.
The confidence level is the probability 1 minus alpha, such as 0.95 or 95%, that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. The confidence level is also called the degree of confidence or the confidence coefficient. The confidence level of 95% is the value used most often.
Let's discuss this concept. In statistics, we deal with a couple of things. One of them is alpha. One of them is 1 minus alpha. Alpha is known as probability of making type 1 error. We discussed that in coming chapters. 1 minus alpha is known as the confidence level. Normally, we want the confidence level to be high, obviously. So 90%, 95%, 99%. It can be any number of your choosing. When you want to do the calculation, for example, one may say, okay, what is the 80% confidence interval you want to find? But here's the concept I want to make sure everybody understands. If I said, I want you to calculate the 80% confidence interval, the confidence level is 80%. Normally, we go for much higher, 90%, 95, and 99. And as far as the 95% is concerned, again, why is this used more than anything else? Well, everybody remembers the empirical rule, the 95% rule, that when you start from mu and you go 2 standard deviations on each side, it covers almost 95% of the data. In fact, it covers about 95.4%. And that is called usual. Do you remember mu plus minus 2 sigma? Okay, so why is it? Remember, mu plus minus 2 sigma was considered usual, and beyond was considered unusual. And so they're all related in that sense. So they have, statisticians have agreed upon this 95% and this mu plus minus 2 sigma. That's why it's used more than anything else. But the confidence level is whatever the question is asking you. If you are on your own and you're working on some project, you decide what the confidence level of that project is for you, and normally no less than 90%. So if you go with 90%, 1 minus that, alpha becomes 0.1, 95% becomes 0.05, and the other one is 0.01. Interpretation, let's do interpreting a confidence interval. Be careful when it comes to interpretation. So there are different ways of approaching it. So let's see how statisticians approach this.
We must be careful to interpret confidence intervals correctly. There is a correct interpretation and many different and creative incorrect interpretations of the confidence interval 0.405 is less than p is less than 0.455.
Correct. We are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the population proportion p. Wrong. There's a 95% chance that the true value of p will fall between 0.405 and 0.455. Also wrong is 95% of sample proportions will fall between 0.405 and 0.455.
A confidence level of 95% tells us that the process we are using should, in the long run, result in confidence interval limits that contain the true population proportion 95% of the time.
This is a graph representing confidence interval from 20 different samples.
The process success rate, a confidence level of 95% tells us the process we are using should, in the long run, result in confidence interval limits that contain the true population proportion 95% of the time.
Let me just quickly recap what's happening on this page. We are working on a project. We decide on the confidence level, and let's assume our decision is to go with the 95%. This is our decision. We have done the sampling. Everything is on us. So when we do the job, we are 95% confident. According to the sample we collected, according to the calculation that we did, we are 95% confident that the interval from 2, in this case from 0.405 to 0.455, actually does contain the true value of the population proportion. It's not that the others that are written here. So get to the habit of sort of memorizing this, and you'll be able to rewrite this. And as far as this last part, confidence interval can be used informally to compare different data sets. This is when we look at test of hypothesis, there are different methods, okay? A traditional method that uses the critical value, we use the p-value, and we use the confidence intervals. We discuss all of them, and that's what is really discussing, and it makes more sense when we come across that. You have your confidence level of 90%, 95%, 99%, whatever it might be, is smacked in the middle. The tails contain the total area of alpha. So that means divided by 2 for each piece.
Critical value is the number on the borderline separating sample statistics that are significantly high or low from those that are not significant. The number z sub alpha over 2 is a critical value that is a z-score with the property that it separates an area of alpha over 2 in the right tail of the standard normal distribution. A standard z-score can be used to distinguish between sample statistics that are likely to occur and those that are unlikely to occur. Such a Such a z-score is called a critical value. Critical values are based on the following observations.
Under certain conditions, the sampling distribution of sample proportions can be approximated by a normal distribution. A z-score associated with a sample proportion has a probability of alpha over 2 of falling in a right tail. The z-score separating the right tail region is commonly denoted by z alpha over 2 and is referred to as a critical value because it is on the borderline separating z-scores from sample proportions that are likely to occur from those that are unlikely to occur.
If you choose 95% confidence level, so what is this area equal to? 1 minus 0.95 divided by 2. 0.05 divided by 2. That means you have the area of 0.95 in the middle, the area of 0.025 to the right and to the left of those values. And those values can be looked up from the table. Finding that from the table, take a look at the graph. So we have 95% in between, and to look up the values, that happen to be a very common value, and you can go look it up from the table. It becomes 1.96, and because it's a confidence interval, it's positive and negative 1.96. So those are the critical values. And these are the critical values for other confidence levels that are common. I highly recommend when we are done, you go to the table, you are going to look at on your own, making sure you can read the table. Make sure you can come up with those numbers. Of course, it's plus minus because remember, the confidence level is smack in the middle. Estimating a population proportion. So in short, the synopsis of what we have done, we have p hat, which is a sample proportion, n is the number of sample values, z alpha over 2 is the critical value, or z-score that separates an area of alpha over 2 in the top right. Actually, for the bottom left is negative z alpha over 2. Sigma of p hat is simply square root of p hat q hat over n. This is the standard deviation of sample proportion. Is the margin of error, and the sample is a simple random sample, SRS, and the conditions that we discussed for binomial distribution should work. And since we are going to go to the z-score, that means we are approximating with the normal distribution, then NP and NQ, or NP hat or NQ hat, whatever we have must be large. How large is good? At least 5. And these are the formulas. P hat plus minus E. What is E? This is what you need to know. This is the value of E. Z alpha over 2, square root of P hat Q hat over N. So those are the formulas that are being used. Let's start with an example.
Assume that a poll of 1,487 adults showed that 43% of the respondents have Facebook pages. A, find the margin of error E that corresponds to a 95% confidence level. B, find the 95% confidence interval estimate of the population proportion P. And C, based on the results, can we safely conclude that fewer than 50% of adults have Facebook pages? Assuming that you are a newspaper reporter, write a brief statement that accurately describes the results and includes all of the relevant information.
The very first thing is, notice again, you have to convince yourself this is a binomial distribution. By now, everybody knows why. There are two outcomes. You have it or you don't. That means a Facebook page, and N is 1,487 with P hat being 0.43. And so now we are going to calculate the E. As you can see from the top, we have the formula for part E. Now, what we really should check, can we use an approximation? We don't have a P, therefore we stick with P hat. Now, instead of NP and NQ, we really should calculate NP hat and NQ hat. When we do the calculation, they are both large, and therefore it's safe to use the approximation. Okay. Now, first, let's go with E. Remember, we want a 95% confidence level. So we already know the answer for 95% is really z-score is 1.96. But just for the sake of argument, if you were to graph it, this is 95%. and the z-score is 1.96. You just plug it in. By the way, q hat, as always, 1 minus p hat. So when you put it in to a formula that is at the top right, E equals z alpha over 2 square root of p hat q hat over n, and of course you have access to a formula sheet, you end up with 0.0252. This is E. And you need that to come up with B. Now, what is the answer to part B? This is the answer to part B. P hat plus minus E. So P hat, which is 0.43, all you have to do, add and subtract this number. In other words, you write down 0.43 plus minus 0.0252. That means subtract this number from 0.43 and it becomes 0.4048. Add and it becomes 0.4552. How would we do the interpretation? It's important to have a reasonably decent interpretation. First, based on the result, can we safely conclude that fewer than 50% have Facebook? Take a look at the interval. Take a look at the interval. You see this interval? Three things happen. Either it's entirely below that 50%. You compare it to this 50%. You compare. If it's below, yes, the answer is yes. If both sides are larger than 0.5, that means definitely larger than 50%. So if both sides of the interval is larger than 0.5, let's say 0.6 to 0.7, I'm making it up, then definitely larger than 0.5. If 0.5 is included, in other words, it goes from, let's say, 0.4 to 0.6, that means precisely we are assuming is about 50%, because we can't say that it's lower or more than 50% because it contains 50%. Yes, because the interval is an interval that is completely below 0.5. Now, writing. So according to this case and our calculation and so forth, we can tell that in 95% of such polls, the percentage should differ by no more than 2.52 percentage points in either direction from the percentage that would be found by interviewing all adults. In other words, what we are saying, in other words, is that we are 95% confident that the interval from 0.4048 to 0.4552 actually contains the true value of proportion P. That's the idea behind this concept. So that's how you do the interpretation. I want to show you how you use, so if you were to use a TI, first you click on stat, then you click on tests. So you click on stats and you find the stats, then you go to the right until you hit tests, and you come on down to find one prop, that means proportion, Z interval. You have to go down and then you plug in those numbers, X and N and confidence level, and it will give you this. So one prop, Z interval, calculate, and it gives you the interval. Why is this different than what we have? When the technology is used, it uses a better value of Z. We use the Z-score from the table. That's why it's an approximation. So we want to be able to distinguish between the two.
A poll of 1,007 randomly selected adults showed that 85% of respondents know what Twitter is. A, find the margin of error E that corresponds to a 95% confidence level. B, find the 95% confidence interval estimate of the population proportion P. C, based on the results, can we safely conclude that more than 75% of adults know what Twitter is? D, assuming that you are a newspaper reporter, write a brief statement that accurately describes the results and includes all of the relevant information.
Normally, we are interested in part B. In order to get to part B, we need to do part A. And therefore, so the very first thing we need to do is recognize it's a binomial distribution, because you either know Twitter or don't. And according to this, N is given, and 85% is P hat. I want to make sure you know, because that came up before, I want to make sure we distinguish between P hat and P. P hat pertains to the sample. Remember, a poll of 1,007, this is a sample. This is a sample size, and it pertains to the sample. Therefore, it's P hat. And so can we use the z-score? Can we use a binomial distribution? We calculate n p hat and n q hat. They must be large. Needless to say, q hat is 1 minus p hat. Now we use the top formula, E equals z alpha over 2 square root of p hat q hat. Again, 95% is common. It's 1.96. If it's not, we use others. And it gives us the following. Now all we have to do, add this number to p hat, also subtract it from p hat, and it becomes the confidence interval. So we want to add and subtract this number from p hat of 0.85. We use the formula for E, and then we add that to p hat, we subtract it from p hat. Now, based on the result, can we safely conclude more than 75% of adults know what Twitter is? What do you think? Yes or no?
Yes.
Yes. Why is that?
Interval is above like 0.75, so then we can assume
Absolutely.
that it's greater.
Perfect. Look at this number, 75%. When you compare it, both of these numbers are larger than 75%, okay? But for the sake of argument, if the bottom was, let's say, 0.7, then we couldn't say so. That's important to see why we can claim that, because it contains 0.75, we couldn't. This one obviously doesn't contain. If both of them are less than 0.75, that means less than 75% of adults know about what Twitter is. Since both of them are larger, they know that. And as far as the wording, we are 95% confident that this interval contains the true proportion. And this is one way to write it. 85% of US adults know that Twitter is. That percentage is based on this poll of 1,007 randomly selected adults. In theory, in 95% of such polls, the percentage should differ by no more than 2.21 percentage points. This is slightly different than what we discussed before. The way you write it, there are really two methods that are correct. This is one, and the other one is that we are 95% confident that this interval actually contains the true proportion of adults that know what Twitter is. We are 95% confident that the interval of 82.79% to 87.21%. The next thing we want to look at is a slightly different example. We mentioned how we arrive at p hat and E. Here's an example.
Assume 70% of the 71 subjects that had smoke therapy did not smoke after 8 weeks and resulted in a 95% confidence interval of 58% to 81%. Find the point estimate p hat and the margin of error E.
So let's see what is given. The confidence interval is given. That means 95% confidence interval is this, according to this calculation. So to find p hat, we use the top formula, add the two end numbers, 0.58 and 0.81, divide by 2. And to find E, subtract and divide by 2. The next topic that is discussed here is a sample size. Suppose we want to collect sample data in order to estimate some population proportion. How many do we need? What should be the sample size? In order to be sure that the margin of error is no more than whatever we decide. So the margin of error, we don't want it to be large, remember that. And that's why you want the confidence interval to be small, confidence level to be high, confidence interval to be small. And so with that being the case, you want to calculate the n. Algebraic, if you calculate for n, that means divide by z, or z alpha over 2, and then square both sides. I'm going to use z instead of z alpha over 2 for just the ease of operations. Now, if you square that, you get e squared over z squared. By z, we mean z of alpha over 2, p hat, q hat over n. And cross product n e squared is z squared, p hat, q hat. And remember, I don't want to keep on writing z of alpha over 2. And so to calculate n, you divide by e squared. This is how we arrive at the formula. Now, what if we don't know anything about p hat and q hat? We go with the worst scenario. What is the worst scenario? P hat equals q hat. So if you replace p hat and q hat with 0.5, then p hat times q hat is 0.5 times 0.5, and that's 0.25, and that's how we arrive at this one. I hope it's clear, everybody. You don't have to come up with the formula. The formula is given to you, but I wanted to see how we arrive at it.
Many companies are interested in knowing the percentage of adults who buy clothing online. How many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? A, use a recent result from the Census Bureau, 66% of adults buy clothing online, and B, assume that we have no prior information suggesting a possible value of the proportion.
Okay, so let's see what's given. Look at the top formula. We want to get to those, and as we go through this, let's see what's given. 95% confidence level, no more than 3 percentage points. That means E is 0.03. And for part A, p hat is given. There's really not much left. We just put it into a calculator. For 95%, everybody remembers we use 1.96, right? So that's a common one. We are going to use that. So p hat is 0.66. We calculate the q hat. Confidence level of 95% gives us 1.96. We put all of that into the first formula. Z alpha over 2 squared is 1.96 squared. P hat, 0.66. Q hat, 0.34, or simply 1 minus 0.66. E, 0.03 squared. Do the math. Now, here's what I want everybody to pay attention to. Regardless of what you have here, you round up. In other words, if it's 957.1 or even 957.01, that is the minimum size you need to be on the safe side. You round up because the size must be a discrete value. You round up. Now, what about part B? You basically use everything the same. Instead of p hat times q hat and plugging in, you just use 0.25. So part B repeats itself, but we use p hat equals q hat equals 0.5. Notice what happens. Again, as I mentioned, we round up, but notice this number compared to this number is what? Larger. Always the second case is larger. What does it mean? Okay, it's a more conservative estimate, meaning if I have no idea what to use, I'll go with the worst case scenario just to be on the safe side. And that means we are going to have a larger sample size. By the way, speaking of larger sample size, if 1068 will do the job, can I go with 2000? Of course. But this is the minimum I need. And remember, we are always restricted by time and money.
A researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary.
As I mentioned, we're dealing with word problems. So can you tell me what's given when we read this question? Because if we can come up with what's given, we are practically done. What is given, class?
P hat, the
Okay, let's start with the first.
40%.
The first number I see is 95%. That is clear, right? It's confidence level, right? And then you said p hat. P hat equals what number?
0.4.
So this is p hat. Okay. So we are reading. And what else is given?
E.
Sorry,
Equals
0.02.
Beautiful. As long as we see those, we are practically done because the formula sheet is available and so is the formula. We're going to put it into the first formula because p hat is known, and because p hat is 0.4, q hat is 1 minus that, which is 0.6. And 95% confidence level results in Z of 1.96. We've already seen that. It's one of those common ones. We've seen it many times. So plug it into the very first formula, and it gives us the following number. And as always, what do? Round up.
A survey of 1,404 respondents found that 323 students paid for their education by student loans. Find the 90% confidence of the true proportion of students who paid for their education by student loans.
We are reading the question, and we need to figure out what is given. If we can figure this out, we are practically done. I start with the first number. What is that?
And
Beautiful. I start with the next number. What is that?
X.
Beautiful. Lowercase x. See, out of 1,400, 323 students paid for their education by student loan, so that is x. And of course, this is your what? Confidence level. So you're dealing with the binomial distribution because either you use the student loan, either or. So that's a binomial distribution. And again, you really have to calculate the p-hat and then multiply by n to see if it's larger than 5 to use the z-score distribution. It is so it's fairly large when you can, because n is large and p-hat and nq-hat will end up being large. So the very first thing is p-hat, where p-hat by definition is what? X over n. P-hat is x over n. Normally we need more decimals if need be, but that's fine. The q-hat is 1 minus that, and np-hat and q-hat are both large. Okay, I didn't even calculate it. 0.23 times 1404 is definitely large. So I don't need to even calculate to have an idea that's large. Okay, it's very obvious that it is a large number. By large, I mean definitely larger than 5. But you're more than welcome to calculate the result. In any event, so now we are going to go with the normal distribution and using the z-score, because remember that is an approximation when we do that. We are going to the normal distribution. Having said that, we need to use this formula for E is z alpha over 2 square root of p-hat q-hat over n, and then you really need this 90% in between. These are the tail, and you need to look up the z-score, and we remember it's one of those common ones, or you can pick it up from the table, 1.645. So if we use that, we are using the top right formula, and we know z is 1.645 because of that 90% confidence level. So you calculate it becomes 0.09. So all you have to do, p-hat plus minus e. Now you're going to subtract this from 0.23 and you're going to add this to 0.23. What does it mean? That means we are 90% confident that this confidence interval of 0.211 to 0.249 does contain the true percentage. So you can be 90% confident that the percentage of students who pay for their college education by student loan is between 0.211 and 0.249, which means 21.1% and 24.9%. Let's look at the last question of the section.
A survey of 1,721 people found that 15.9% of individuals purchased religious books at a Christian bookstore. Find the 95% confidence interval of the true proportion of people who purchase their religious books at a Christian bookstore.
Let's see what's happening. Again, it's important to see and read and understand what's given symbolically. So the very first number is what? 1721. What is that?
N.
Everybody?
N.
That's n. 15.9% is the next number I see. So this is n. What is that 15.9%?
Well, you can find X if you multiply it by N.
Yeah, but that is p-hat. Okay, that's the percentage. Okay. And what is the confidence level? 95%. And so with that being the case, any 1721, p hat is 0.159 with the confidence level of 95%. Now, we can calculate the E using the top right formula. And for 95%, remember, we use 1.96. We've been using it. So I want to show you a slightly different method of writing this. You can calculate E and then add and subtract. Or you can write it in this fashion. I would actually stick with calculating E, and therefore that would make it easier. I would calculate this E, and I would calculate it just once, and subtract and add, and the final answer becomes what you see. 0.142, P is between 0.142 to 0.176.